Hi everybody, good to see you again. This is the lesson plan for maths, for level 2 maths on the Monday. Okay, I've sent you all emails with the details and with the worksheets. So what I want to do today is just go through the lesson plan with you so that you know what I'm looking for. Okay, so we'll go through it quickly and I'll reference the worksheets that I've asked you to do as well. So we've been talking about area in recent weeks, if you remember, and what does that mean? How much space does something occupy, or how much space does it take up? Okay, so if I talk about my mobile phone here, if I put it on a table or on in my hand, how much space is it taking up? Okay, that's the area. Area is a two-dimensional measurement. If you remember two dimensions, it's got length and width, or width and length, it doesn't matter which way you do it, but it's two dimensions. And if you remember, we calculate area by saying area is equal to length by width. Okay, and there's a little picture of it here. So the blue part here is the space that this rectangle occupies, so that's the area. The perimeter is the distance around the rectangle. Sorry, brief interruption there, so I'm back now. Okay, so like I said, the area is the blue space that's occupied by the rectangle, so the length by the width. The perimeter is the distance around the edge, and that's just a one-dimensional measurement. It's just a distance. You can draw it out on a ruler or a measuring tape. Okay, so that's what we've been working on till now. But, sorry, went down too. What if we want to know how much space a container takes up, or something that's a 3D object? So we're going to talk about volume and capacity. Okay, what does volume mean? One answer is that volume describes the amount of space that a 3D object occupies. It's measured in what we call cubic units, or centimeters, meters, whatever it might be. So if you remember, when we calculate the area of something, we have squared units. When we're talking about volume and capacity, we're talking about cubed units, okay? And I'm going to use a Rubik's Cube to try and demonstrate that to you, because it's a little bit of a difficult concept to understand, okay? So let me just come down here a bit. Oops. The arrows are a little bit all over the place here. So if we consider the Rubik's Cube above, the face of the Rubik's Cube that is placed on the surface, so that's the bottom of it, and I have a Rubik's Cube here. It's not made, but it's the same thing. Okay, so I'm talking about this face. When you put it on the table or in your hand, this is the face, okay, that's placed on the surface. It has length and width, okay? However, this shape also has height. You see that? So that's what I'm pointing out here as well on the document. We've got length, we've got width, and we've got height, okay? So that's 3 dimensions, okay? We're into our volume measurement now, not area anymore. So we have 3 dimensions. Whoops. So the volume, back up here, sorry. Oh, sorry guys, bear with me. I'll do it again. There we go. So the volume of the Rubik's Cube is the area, okay? The length and the width of this multiplied by the height, okay? That means that volume is calculated using V equals length by width by height. And we can see that the length is 3, okay? We want to look at it 1, 2, 3. That the width is 3, 1, 2, 3, and that the height is 3, 1, 2, 3, okay? So the volume is 3 multiplied by 3 multiplied by 3. And we get 3 by 3, which is 9, multiplied by 3 again, that's 27 cubic units, okay? So as I say, I'm reviewing this in the video now to help you understand it, so I hope it's making a little bit of sense to you, but this picture below should also make sense. And I'll show you on the real Rubik's Cube as well, although I'm not going to take that apart. So here's the Rubik's Cube, and you can see that 3 of the cubes that make up the Rubik's Cube have been removed. Do you see them? Okay, so if we go back to my real one here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes that make up this first bit. Then we have another 9 in here, in the middle, sorry, can you see that? Another 9 in here in the middle. And then we have another 9 at the back, okay? 9, 9, and 9 make 27. So what they've done here in the document is they've taken off 3 of the cubes, okay? Each one of these is 1 cubic unit, okay? So we said there's 27 cubic units in our Rubik's Cube. These are 3 of them, okay? So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll have 9 on this layer on the bottom and 9 on this layer. Sorry, 9 on the layer in the middle and another 9 on the bottom layer there. Okay, so that's 27 altogether. Okay, we know from our wrong button. We know from our calculation above that there are 27 cubic units. That's what we described in here. Okay, that make up the whole Rubik's Cube, and 3 of them have been removed. Each of those small cubes is one of the cubic units. All right. This is just another demonstration of how we calculate the volume of a cube or a cuboid. So whether it's a cube or a cuboid, you calculate the volume the same way. It's length by width by height. Or length by width being area. So it's the area of, let me get a cuboid. Okay, here's a Terry's chocolate orange. That's a cuboid. Okay, you can see that. I'm going the wrong way, sorry. Okay, so length by width is the area and then the height. Okay, so whether it's a cube, like the Rubik's Cube, sorry, okay, or a cuboid like this one, you measure the volume the same way, length by width by height. Okay, so that's what this diagram is showing you. All right, so let me move down. There we go. Now, I have sent you the worksheets to practice this, okay? I'll just show it to you briefly. Hopefully it'll let me. Oh, this is one I don't have open, that's great. Oh, there it is. Hold on, find the volume, that's the one I want. Okay, so here is the worksheet that's going to let you practice that a little bit. It's telling you the same thing. To find the length, width and height of each rectangular prism, okay? Use the information to work out the volume. In all examples, a cube represents a cubic centimetre, okay? So they've just given you the specific units of measurement here. So your answer is going to be in cubic centimetres because we know it's centimetres. And you can see here the volume formula is given as length by width by height, or L by W by H. Okay. The volume of a rectangular prism or a cuboid, same thing, is the same as the number of cubes that fit inside it. So the example it gives here is length is 3. Okay. Width is 6 over here. And height is 2, okay? So the volume is 6 by 3, which would be 18, by 2 is 36 centimetres cubed. Okay, so it gives you a couple of problems to work out there. So you can fill in the length and the width and the height for each of those and work out what the cubic volume is, okay? There are answers there. Please don't look at the answers until you've tried it, but if you're getting stuck, do go ahead and look at the answers, okay? So that is the first worksheet. Okay, let me see what's next. Okay, now I do want to mention very briefly capacity. I've sent you a couple of worksheets on this as well. What does capacity mean? So one answer is that, sorry, screen again. What does capacity mean? One answer is that capacity is how much a container can hold. Okay, so this is a Rubik's Cube. It can't actually hold anything because it's not hollow. Whereas this box here, we can open that, okay, and we can put something inside. Okay, so that has capacity. And capacity, unlike volume, is measured in metric units like litres, millilitres, grams, kilograms. So you can imagine lots of things in your kitchen have something inside them, and we can measure that in what we call weight or volume with litres and millilitres. So, sorry, have a look at the worksheets that I sent via email and have a go at the container capacity homework sheet and the measuring capacity worksheets, okay? There is another one, I think it's called capacity problems. Don't worry about that for now, okay? You will need a measuring jug and some containers from the kitchen to do this, and I just took a photo of some of the containers that I have here. So some of them are food containers. You can see milk, yogurt, jam, water, oil, more oil, and then some measuring ones, a measuring jug and this little small measuring glass that I have, and also just some random containers. You can try and guess how much water that you will get in each of those, and then if you have a measuring jug you can go and measure it and see if you're right. Okay, so just to show you the two worksheets. Okay, let me see, where am I? Sorry. There we go. There's the, it just explains that there's 100 millilitres in 1 litre. And there are 100 centilitres in 1 litre. Don't worry if that's confusing you a bit. We'll come back to that at another time, okay? Have a look at labels on cartons or bottles at home and write down how much fluid they contain, Okay, so state whether this is more or less than a litre if you know. So the example that you have there is a Ribena. Sorry, if I can move down. Hold on, I'll go over here. There we go. Right, this doesn't want to move for me. That's just great. There we go. Finally. Okay, so you've got a Ribena carton there. Okay, it's telling you it's 200 millilitres. That's less than 1 litre because we know we need 1,000 millilitres in 1 litre. So 200 millilitres is less than 1 litre. So have a look around the kitchen and see what else you can find and see, can you say, is it more or less than 1 litre? Okay, so it just gives you some space to do that in the rest of the worksheet. Okay, and the other worksheet then is, we've done that one, we've done this one here, measuring capacity. Okay, so first find some containers at home and order them on your table from the biggest capacity to the smallest, okay? Then if you can, fill your containers with water and pour them into the measuring jug and read how much water is in the jug for each item and record it in a table, okay? So which container held the most, which container held the least, okay? So you can use as many as you want. This one's got 4 there on the first page. And then for some other containers that don't have measurements on them, estimate which you think will hold the most and the least water, okay? Then fill your containers with water and pour the water into the measuring jug and read how much water is in the jug and record your table, okay? So which container has the biggest capacity, which has the smallest capacity, and where you need to get to guess the right amount, okay? So that's what those two are. You can do that at home yourself. You can get the kids to help you if you want, and it can be as much fun as you want it to be. There's no pressure on getting this done, quickly. You can do it at any time this week. So have a go at that and see how you get on. Okay.